All right, welcome back everyone for another deep dive. Ever been stuck in a foreign country, you know, trying to charge your phone, but the outlet's all wrong?
Oh, yeah. Been there. Totally frustrating.
You need that adapter, the one that kind of like changes the shape of the plug so it actually fits.
Exactly. Makes the incompatible compatible.
And in software, we bump into the same sort of problem all the time when different parts of a system or maybe a new library we want to use just don't plug in together neatly. Their interfaces clash.
Happens all the time.
It's like trying to fit a square peg in a round hole. And today, we're going to look at a pattern, a design pattern that solves this very problem, the adapter pattern. It's a slick way to make these incompatible software components work together.
I like to think of it as our software travel adapter.
Perfect analogy. And this is super relevant, especially for, senior engineers out there. You're often the ones bringing in some cool new tech from a vendor, trying to integrate it into an existing system, a system that's probably already pretty complex.
Yeah, you've got this established system humming along, doing its thing, with its own way of doing things, its own expectations.
Right, its own rules.
Then you find this amazing third-party library could really boost your capabilities, add some serious functionality. But the way it's designed, the methods it uses, the way it talks, so to speak, is just different.
Different language.
Exactly. And, if you're prepping for a senior role, you got to know the best practices. Rewriting your existing code to match this new library, that's a no-go.
Yeah.
Huge time sink, risky, and frankly, just not elegant.
Yeah, and not to mention trying to mess with the vendor's code directly. You might not even have access to it in the first place.
Right. So what do? That's where the adapter pattern comes in. It's like having a diplomat, a translator between these two pieces of software that speak different languages.
It's like a peace treaty.
It lets you create this go-between, a class that acts as a, translator. This adapter takes the requests from your system and reshapes them, rephrases them into a format that the vendor's library understands.
So the original system and the new library, they stay the same, untouched. The adapter handles all the communication.
Exactly. And the beauty is neither side even knows the adapter's there. Everything just works.
It's magic. Well, not really magic, but...
Elegant code. Okay, so let's get to the heart of it. What's this core idea behind the adapter pattern?
Yeah.
We're taking one way of doing things, one interface, and think of an interface as a contract. It specifies how you interact with something, like an object in this case.
Yeah, it's like the instruction manual.
Yeah. So we're taking this interface, this contract, and we're converting it into another one that your existing code expects. It's all about bridging the gap.
So picture this, right? Imagine a system built around the concept of a duck. It knows ducks have certain behaviors. They quack, they fly.
Basic duck stuff.
Right. We might even have a specific kind of duck in our code, like a mallard duck. It does all the duck things.
What?
Quack and fly.
Okay, got it. Standard duck behavior.
Now, a new bird walks onto the scene, so to speak, a turkey.
Okay, a turkey. What about it?
Turkeys, they don't quack.
No, they don't. They gobble.
Exactly. And while they can technically fly, it's usually just a short burst, not like a duck's graceful flight.
More of a hop and a flap.
Right. So let's say we have a wild turkey class, does the turkey things, gobble, and this short flay.
Okay, so we've got our duck and our turkey. Where's the problem?
The problem is, our system is designed for ducks. It expects a duck, knows how to talk to a duck, but we want it to work with a turkey.
I see the issue. You can't just swap them out like, hey, system, here's a turkey, treat it like a duck.
Nope, not going to work.
Right. So how do we bridge this gap? This is where our hero enters, the turkey adapter. This adapter class, its mission is to make these two, the duck expecting system and the turkey, understand each other.
To translate.
Exactly. First, it implements the duck interface. It's essentially saying, hey, system, I can talk duck. I've got the quack and fly methods you're looking for.
It's putting on a duck costume.
Exactly. But underneath that costume, things are a bit different. Inside the turkey adapter, it's actually holding onto a turkey object.
Okay, so it's a duck on the outside, turkey on the inside.
Precisely. So when our system, thinking it's talking to a duck, calls quack,
Yeah.
what actually happens, the adapter says, hold on, let me translate this.
And calls gobble on the turkey it's hiding.
You got it. It delegates that call to the turkey's gobble method. It's saying, when you ask for a quack, I'll give you the closest turkey equivalent I can.
Pretty clever.
And flying, that's another challenge. Right?
Yeah, a duck's fly is a nice long flight. A turkey's not so much. How do you adapt that?
Right. So the adapter's fly method has to get creative. Instead of calling the turkey's fly just once, it might call it multiple times, maybe like 5 times, really quickly. sort of mimic that longer duck flight.
It's like giving the turkey a jetpack.
Kind of. Now, is it a perfect imitation? Not really. But it gets the job done, allows the system to work without knowing it's not actually dealing with a true duck.
So let's recap the players here. We have a target interface, which is what the client expects. In our example, that's the duck interface. Then there's the client itself, the code that's using that interface. The adaptee is the one with the incompatible interface, our turkey in this case.
And then the star of the show, the adapter, the turkey adapter, making it all work. It implements the duck interface and holds onto a turkey object. Translates everything.
So the duck interface is the target interface, the system expecting a duck is the client, the wild turkey is the adaptee, and the turkey adapter is, well, the adapter.
Exactly. So imagine this. The client code wants a duck to quack. It calls quack, but it's actually talking to the adapter. Behind the scenes, the adapter says, turkey, gobble.
And the client just hears a sound. It doesn't know it's actually a turkey gobble.
Right. Client's none the wiser.
Seamless. Now, there isn't just one type of adapter, right? We've been talking about one specific way of doing it.
You're right. This turkey adapter is an example of an object adapter. What makes it an object adapter is that it uses object composition, meaning the adapter has a turkey object inside of it.
It contains a turkey.
Exactly. It holds a reference to it. Now, this is super flexible, right? Because this adapter could work with any kind of turkey, any subclass of turkey. Doesn't need to be rewritten for each one.
Oh, that's smart. So what's the other type of adapter?
The other main type is a class adapter. It takes a different route. Instead of holding an instance of the adaptee, it uses multiple inheritance, meaning it would inherit from both the target interface, which is duck in our case, and from the adaptee class, the turkey.
So it's like kind of a hybrid inheriting traits from both?
You got it. And it would override the methods of the target interface and directly call the inherited methods from the adaptee. So in our silly bird example, a class adapter would be a class that both is a duck, inheriting the duck interface, and is also a turkey by inheriting from the turkey class.
Whoa, a turducken of code.
Kind of. Now, here's a catch, especially for Java folks. Java doesn't do multiple inheritance of classes directly. So while a class adapter is theoretically possible, you'd see it more in languages that support that. But in Java, the object adapter, the one we talked about first, is the way to go. Much more common, way more practical.
So in Java, stick to object composition. Got it. Now let's move away from our birds for a second. Can we see a real-world Java example of this?
Absolutely. A great example is the enumeration interface and the iterator interface. You'll run into these when you're dealing with collections of data, especially when working with older Java code.
Classic legacy code problem. So take us back. What's the issue?
Okay, so in older Java code, you'd see the enumeration interface all the time. It was used to, go through elements and collections. Think vector or hash table.
Old school Java.
Right. And enumeration has two main methods. It has more elements and next element. Simple, straightforward.
Check if there's more, get the next element.
Yep. But then Java evolved. We got the newer collection framework, and it prefers the iterator interface.
New kid on the block.
Exactly. Iterator has similar methods, as next and next, but it adds a key one, remove. This lets you delete an element from the collection right as you're iterating through it. Pretty handy.
Makes sense. So what's the incompatibility here? Names are a little different, but...
The big one is that missing remove functionality in enumeration. You can't just use an enumeration where an iterator is expected. The interfaces don't line up.
Perfect scenario for an adapter. Can you walk us through it?
Right. So we could make an enumeration iterator class. It would implement the iterator interface. So it needs to have has, next, and remove methods.
Got to fulfill that contract.
Yep. But cleverly, it would also hold a reference to an enumeration object. This is the one it gets from the legacy code.
Okay, so it's got the iterator face, but the enumeration heart.
Exactly. Now, for has next, it would simply call has more elements on that underlying enumeration. And next would call next element, straightforward mapping. But what about remove? Remember, enumeration doesn't have a way to remove elements. So what does our adapter do?
This is where it gets tricky.
It'd have to make a compromise. Since the enumeration can't do it, the adapter can't magically add that functionality. The best approach. The enumeration iterator's remove method will throw an unsupported operation exception. It's a clear signal to the client code. Hey, I know you expect remove, but sorry, the underlying enumeration just can't do that.
It's being honest about its limitations.
Exactly. As a senior engineer, you'll hit situations where you have to bridge technologies that just have different capabilities. Perfect mapping isn't always possible.
Right, you have to be pragmatic.
Exactly. Okay, so taking a step back, Let's talk about why we use adapters. What are the big wins?
And are there any downsides? Things to watch out for.
Good points. Advantages. Reusability is a huge one. Adapters are all about using existing code, even if its interface is a bit off. Saves you tons of time and effort. No need to reinvent the wheel.
Especially when you're dealing with those legacy systems that are everywhere.
Right. Adapters can be your best friend there. Plus, you get better decoupling. Your client code only sees the target interface, that adapter interface, not the messy details of the adaptee.
So you can swap out the adaptee later if you need to.
Precisely. Just create a new adapter for the new component, and your client code doesn't even know the difference. Makes your system way more flexible, easier to maintain in the long run. Adapters promote this loose coupling, where components are less dependent on each other's specific implementations. It's like having modular building blocks. You can rearrange them, swap them out as needed, without bringing the whole structure down.
And all the messy details of making the two interfaces work, that's all tucked away inside the adapter. Good encapsulation.
Exactly. Now, one thing to think about is the granularity of adapting. Sometimes it's simple, just renaming methods, like our has next to has more elements example.
Just a little tweak.
But other times, it can get more involved, like with the duck and turkey flights. You might have to transform data, make multiple calls to the adaptee to do what the client expects. The complexity depends on how different those interfaces are.
Makes sense. You also mentioned two-way adapters before.
Oh yeah, those are cool. They implement both interfaces, the target and the adaptee. This way, one object can be used in two different ways by different clients.
It's like a universal translator.
Exactly. Think of a legacy system that needs to provide data in an old format to some clients, but also consume new format data from others. A two-way adapter can handle both, bridging the old and the new.
Very versatile. Now, what about pluggable adapters?
Those are all about designing for flexibility from the get-go.
Building in adaptability.
Right. One way to do this is with delegate objects. Instead of your class depending directly on a specific adaptee, it uses a delegate object for certain tasks. By providing different delegate implementations, you can adapt the class's behavior without changing the class itself.
Oh, clever. So it's like having different tools you can plug in depending on the job.
Precisely. You could also use configuration or dependency injection to decide which adapter to use at runtime. It's about having options, being adaptable, without getting locked into specific implementations.
That's powerful. So to wrap this up, for anyone prepping for those senior software engineer interviews, knowing the adapter pattern is key. Shows you can think about system design, handle integration challenges, and build flexible solutions.
Couldn't agree more. In senior roles, you'll be dealing with complex systems, integrating third-party services, modernizing legacy code, working with different teams. The adapter pattern is a must-have in your toolkit.
It's a sign of a seasoned engineer knowing when and how to use it.
Absolutely.
So here's a final thought for our listeners, something to ponder. As you're working on projects, think back to those times when two components just didn't play nice.
Yeah, we've all been there.
Could you have used an adapter, even if you didn't call it that at the time? Maybe it could have made things cleaner, more elegant. Having this pattern in your back pocket, knowing how to spot those interface mismatches and bridge the gap, that's valuable. It's a key skill for any senior developer.
It is. It's about thinking ahead, designing for change, and making sure your systems can adapt to whatever the future throws at them.
Great advice. Well, on that note, thanks for joining us for another deep dive. See you next time.